Hey everybody, this is Games Plus James and welcome back to our 2D platformer tutorial here in Unity, working on our little 2D platformer game. So in today's episode we're going to take a look at adding a health system to the game for the player and for the enemies. But before we jump into that, we're going to just do a little not a little fix, but just a little option on. Last episode we added the ability to throw the little ninja stars or fire any projectiles really, but I got a couple of questions asking like if you wanted your player to regularly throw the things so that you could hold the button down and he'd keep throwing them rather than having to press it each time. How would you do that? So we'll cover that very quickly. It's pretty simple, to be honest. So all we have to do is go to our player controller and we'll open that up here in Mono Develop. Pop it open here. And we're just going to add a couple of little variables onto here, just down here. We'll say public float shot delay, and that'll be how much time there is between each shot, basically. And then we'll have a public float shot delay counter. So what we'll set the shot delay. Actually, we can make that a private float because we won't need to do anything with that outside. So we'll set the shot delay, and then in this, no, not even in the start. Actually, when the button is first pressed down. So where is our? Here we go. There's an ninja star thing. So when the button is first pressed down, what we'll do is we'll say, what do we call it? Shot delay counter is equal to shot delay. So we're gonna add another little thing here for if input dot get key. So before we said get key down for when we press the enter button, and get key down gets it at the moment it's pressed and only in that moment. But if you have it as get key, then it'll check if the key is still being held down the whole time. So we'll put the same key code in here again. So key code dot return. Okay, and we'll make our squiggly brackets here. So now when the button is being held down, we want the shot delay to kind of go to tick downwards and count down to when it can fire another shot. So what we'll say here is we have a shot delay counter, so now we want to make the shot delay counter minus equals time dot delta time. So what that'll do is it'll count down the time between since the last frame that happened, basically. So it'll gradually count down. So say we have shot delay is 1 second. That'll make a countdown from 1 second downwards. Okay, so that's counting the way down. And then if shot delay... Oh god, we're doing weird things. Let's just delete the shot delay counter is if it's less than or equal to 0. So once it's counted down from 1 to 0. If it's that, then what we want to do is set the shot delay counter back up to the shot delay again. So once it hits 0, we want it to go back up to 1 and also fire another ninja star. And the reason we want the first ninja star to be thrown straight away, like that. So then afterwards, then we have all this counter counting down and all that fun stuff. So now if we save this and we pop back into the game, this should solve that little problem. So basically, if you want to have like a machine gun on your character or anything like that. Okay, so where is our player? Here he is. Scroll down here. Oh no, we got an error. Oh, I didn't even see that. Where is that on? It's on line 83. 83 is here. Oh, look at that. Sure, we didn't remember to put our semicolon at the end of the statement. Excuse me. Okay, look, we're just doing things wrong all over the place here. This should be a capital G here for get key. See, sometimes Mono Develop is supposed to like fill in those little things automatically, but sometimes it just decides not to, and then sometimes it decides to fill in the wrong one that you don't want. It's a little bit finicky sometimes, but it's okay. We hit play here. Oh no, we shouldn't hit play. That was stupid because we don't have any delay between our shots. If we were to do it now, we've got too many. They're going mad. We don't need that. So we'll put this at say 0.2. That should be enough time between each shot. So now, yeah, look, there we go. Now he's throwing out the diamonds. No, the ninja stars lovely, and they're all doing whatever damage they can do, killing our little friend here. But they look a little bit bland, don't they? They're just kind of going in a straight line like that. That's not very interesting. So let's do something to add some motion to the ninja stars. Now, it'd be interesting to make them spin in the air, and we could do that using the animation system. That would be an idea, but it'd be much simpler if we can just do it through the script attached to each ninja star. So let's go to our ninja star controller script. We'll pop this open, and it opens. Here we go. So we're going to add a little bit of a public float here. Yeah, public float rotation speed, we'll call it. And this will be how fast the object rotates in the air. And then in the update function, basically all we're going to say is rigid body 2D dot angular velocity. So that determines how much spin the object has, basically. So rigid body 2D dot angular velocity is equal to rotation speed. And much like we did with the determining which direction the object should go, we want it to spin different ways depending on which way the player is facing. So here we have the speed being set to go either left or right. So within this, we're going to add some curly brackets around this, because now this if statement has more than one call to it after this. So we'll just say rotation speed is equal to minus rotation speed. So that'll do the exact same thing. It'll decide whether the player is facing left or right, and it'll rotate it the opposite direction. Okay, so if we go pop back into the game here, and we click on our ninja star, once this compiles down the corner, should be okay. Here we go. So rotation speed, and you can fiddle around with this, but the value that I found works for me the most sensibly is minus 360. I think I'm not 100% sure of how the value works, but I feel like that's one full rotation per second, maybe, or something like that. I'm not sure, but we hit apply there to make sure the changes are applied to all the prefabs. And now if we hit play and get the game going, so you can see that one's spinning away, and look, spin. It looks a bit more kind of natural and looks more fun for everybody. Just as an example, we'll slow it down just to like 180, say. Oh wait, no. No, it does. They're not going much slower, are they? We make it 50. Huh. Interesting. Well, let's just do this here. I'm very curious as to why that isn't. I'll tell you why. Because it's not applying to the other prefabs. That's why it's not doing anything. So if we hit 180 here, and then hit apply, because you can't apply to prefabs like that when the game is running. That makes sense. So we'll throw another one here. See, they're turning a lot slower there now. So it's up to you, obviously, what speed you think feels right for something like that. And obviously, if you had like bullets or something, you probably wouldn't really want them to be spinning in the air. But you might either. You never know. For your own game, multiple different purposes could be used. But anyway, let's continue on to the main focus of this episode. What we're going to do is we're going to first create a health system for the enemy, which should be relatively straightforward and pretty easy too. So we'll create a new C# script here, and we'll call this enemy health manager. And we'll just open this up here in MonoDevelop as well. And because the system we used to have in place was on our ninja stars here. So our ninja star has the death effect for the enemy, and also has the points that you will get for killing any enemy, which isn't really, it's a super simple way to do it and very straightforward, but we want the enemy to be actually dying and the enemy themselves giving us points, so that we can get different points values for different enemies, have different effects when each enemy dies. If you want your enemies to explode or something like that, you could make an animation like that and put that in there. Various different things you can do. But yes, so what we're going to do first is we're going to add a couple of little variables that we're going to use. So we will have to have a public int health, which is obviously the enemy. Well, actually, we'll call that enemy health, just so we can remember, just in case there's any other kind of conflicts with anything else later on. So enemy health, we'll need a new det effect object, public game object det effect. Oh, not sevens. Perfect. And then yes, we also want the player to get a certain amount of points when they get killed, or when the enemy gets killed. So points on det, we'll call that. Okay, so in the start function we won't have anything happening. In our update, basically all it checks is that if the health, if enemy health if enemy health is less than or equal to 0, then make some curly brackets here. Oh, there we go. We want to instantiate that det effect object. So instantiate det effect at transform, not capital T. See, this is one of the examples of MonoDevelop putting up the wrong option that you don't really want. Transform dot position and transform dot rotation. Perfect. And then we want to add the points. So we have our score manager static variable thing. So score manager dot add points, and we put in the points on det into that. Perfect. And then we will just destroy game object. So that'll remove the enemy from the scene then. And that's perfect. But we want to add how. At the moment, there's no way to determine how his health has been taken away, and we'll very simply just add a tiny little function here. So we'll just public void give damage. We'll put an int, and we'll call this damage to give. Put our little curly brackets in. Oh, don't need that many. And basically, all this will do is, like, this will be called from, for example, this will be called from the Ninja Star controller script. We're gonna rewrite that in a second. And literally all it'll do is it'll take the current health and it'll say enemy health is minus damage to give. So however much damage you want to take away, that'll take away from the enemy. And that's it. That's all we have to add on to the enemy health manager. But that by itself at the moment, that won't do anything for us. It'll still do the exact same thing. We're still killing the enemy with the ninja stars and making the det effect and all that stuff. Although we haven't added it to the enemy yet, so that won't really show anything. Where's our enemy? We will add our enemy health manager. Perfect. So we'll give him like 3 health, and we'll stick with 500 points when he's killed. But at the moment, that won't do anything. We'll still instantly kill him. See, because the ninja star at the moment is determining what is killing the enemy. So what we need to do is adapt our ninja star controller script slightly. So what we're going to do is, at this point here where it checks for the enemy, very simply, instead of all this stuff where it has to instantiate the thing, destroy the other object, add the points, we'll just comment that out for now, just in case if you want to stick with the same way of doing it, there's no point in deleting all the code. But what we're going to very simply add is other dot get component, not get type, other dot get component, and we're going to put the enemy health manager script in there. So it'll look for the enemy health manager on the enemy, and then within that it'll go to the give damage function, and then we'll pass in. Oh, we haven't added a variable. Actually, yes, that's one thing we're missing. We need to add a variable here, a public int, because we're using ints for the health, because you don't want them having like 3.4 health. That's kind of awkward. So we'll go public int. We'll just call this damage to give. Just keep it nice and simple. So give damage to give. So that'll just add whatever damage you have on the Ninja Star controller to the enemy, and it'll slowly take away his health. So now if we pop back into the game, go to our Ninja Star here, once it's finished compiling down in the corner there, we'll scroll this down, here we go, damage to give, we'll just set that to 1, hit apply, and now when we play the game, he should take 3 hits before he dies. So he's walking there, 2, oh well, if you don't attach a det effect to the enemy, then you're going to encounter a problem like this where the whole game freezes. So I'll just flash forward to when the game stops being frozen. Okay, here we go. It's working again now. So we need to just go to our enemy. See, we have our det effect here. We'll go to our prefabs and grab the det particle effect. Pop that in there. And this time, once we hit him with our 3 ninja stars, as you can see, something was happening when we hit him with 3 stars last time. So now we'll go 1, 2, 3. Bam. There we go. Enemy destroyed. No need to worry about him anymore at all. The only problem now is, though, so our enemy has some health, but our player is just, he's still getting instantly killed. And maybe we don't want him to be killed straight away by the enemies, because the enemy, he's not super violent. All he's doing is like bumping into you. But we might want our spikes to stay instantly killing the player. So rather than rewriting our current kill player script that we have, we'll write an additional one that we're going to add to the enemy instead of the kill player script that we have attached to him. So we have the kill player script here. So what we're also going to do is create a little counter in the top up here to show how much health we have. So we'll go into our canvas here and we'll see we have our score title and our score counter. So we're just going to duplicate that score title and we'll rename it as just health, if I can spell it properly, health title. We'll duplicate that again and we'll call this one health counter. So now we grab the 2 of these and we'll just, if we just zoom out up to them here, so we'll just grab that and pull that down to around about there, and we'll get our health counter. We'll align that to the right just like that, and they're perfect. So now, and we'll just add in, we'll just say 3, just so we can see roughly what it would look like. And we need to change the score here to say health. So score value will go up and our health value, that'll go down. Perfect. So now we need to go back to our scripts here and we're going to add a new C# script and call this we'll just call it health manager, because this will be the main manager that we use for the player. So health manager, we're going to load that up in monodevelop, and we'll actually create another one here which we'll come back to in a second. But in order to hurt the player, we need a special script that won't just kill him straight away. So we'll go for, instead of kill player, we will just say hurt player. Hurt player on contact, because we will probably have different ways that we want to hurt the player in the future. As sadistic as that sounds, it's part of the fun of gaming. So yes. Now our health manager is going to be very similar actually to our score manager, which is here. It's going to use some of the same basic ideas that we had from that to show it up on the screen. So we'll just pop that beside here. So score manager, we're going to need the same. We're going to need a score. We're going to need a text like that. So we'll pop that in here. We won't, well, it won't be called score, but we'll call that, say, well, we'll need 2 variables here. Now that I think about it, we'll need this static one will be player health. So this will be the one that is being modified the whole time, and we'll need a value to reset when the player dies. So we'll need public int max player health. And perfect. So now so we have our text here, but you can see it's in red. And you have to remember that when we made our score manager, we added using Unity engine.ui, and that's to use any of the UI elements that are in Unity, like we said before. So we'll pop that back in here again. Also, we'll just save this, just convert it. We'll just save it just to make sure we're keeping track of things. We're also going to add the level manager in here, because we'll be using the level manager to respawn the player. And we're not going to make too much changes to the respawn the player behavior, but there will be a slight change we have to make. But that's okay. So we got a private level manager, and we'll just call this level manager, just so it's nice and easy to remember. So in our start function, we'll, much like we did with the score manager here, we'll do our text is get component. There we go. We'll set our player health equal to our max player health. And we'll also get our find our level manager in the scene. Level manager is equal to find objects of type level manager. So it'll look for the level manager in the scene, and it'll find it, and then it'll know which one it's interacting with. And much like we had with the enemy health manager, basically what we want in the object function is just for it to check and see if the player is if the player's health is less than 0. So if player health is less than or equal to 0, then what we're going to do is just call from the level manager dot respawn player. And that's all we'll need to do for that little bit. And also in our update, we want it to be telling the text object on the screen how much health the player has. So text dot text. So that'll look for the text component of the text object that we have right up here. So text dot text is equal to, we put these little things just to indicate that we're starting a string that will not have anything else in it apart from our player health. And if you didn't get this, it would throw up an error when you're trying to convert. This is looking for a string of text, and if you just pass in this int value that we've set up here, then it'll go, oh no, there's something wrong here, I can't handle this. So what you do is just add these little quotation marks here to make it realize that it's making a string out of this collection of stuff that we've added there. Okay, so that's our basic of our player health, or our checking to see if our player has died, and we're going to need a couple of extra little functions. So we need a way for the player to get hurt. So we'll add a public static void. So this will be able to call from anywhere. Public static void hurt player. We need to make these capital letters. Hurt player, and this will need to take in a value as well. So int damage to give. We'll stick with that naming convention. Add our little squiggly brackets, and now just in here, same as we did with the enemy health manager, is player health minus equals damage to give. Perfect. And the one other thing that we're going to need is resetting the player's health back to full. So here we're just going to say public void full health. So as quickly as, and much like we did up here in the start function, we'll just copy this, paste it in there. So we'll just save everything, and now that's our health system all set. All set up. So the only problem now is we haven't got any way for the player to get hurt properly. Oh god, got some kind of error here. Health manager line 7. Ooh, 7. Public int. That doesn't make any sense. We just need this just to be public int. There we go. It is one of the very handy things about Unity. It does very good at, like, if there's an error in your code, it's very good at telling you where that error probably is. Of course, it doesn't account for like you coding weird things weirdly, but if there's an error message popping up, it's usually very helpful at telling you where the problem is. So now we start the game here. We actually haven't attached the script to the player, so nothing's going to happen. We add a component player. Oh no, it's just health manager, sorry. Health manager. And we say the player's health is 5, just so he's more powerful than his enemies. So now when we hit play, this health should go up to 5. No, it did not. Well, that's not very helpful for anybody. What is it looking for here? CS 31. 31. Text.text. Oh, because I'm adding it to the wrong thing. That's what's happening. You're not supposed to add that to the player at all. You're supposed to attach that to our text script that's counting how much health we have. So we'll just remove this component. It's always important to make sure you're actually putting things in the right place, of course. So we'll go health manager. Just pop this down again, and we will add 5. So now this time we'll press play, and the health should pop up to 5. But the only problem now, of course, being that we don't have any way for the player to get hurt. So our enemy, he just kills us instantly. our health just stays the same. That's no good to anybody. So we need to add our hurt player on contact script, or adapt it slightly. So we have our hurt player on contact here, and again, this is going to be relatively straightforward. There's nothing too much to this. There's just a value that we want to hurt the player by. So public int damage to give, we'll stick with again. Damage to give, and much like, do we have our kill? We don't have our kill player one open. We'll just open this up here. If it'll open up, here we go. So here in our kill player script, we had to get the level manager because that's the element that's killing the player, but we don't need to worry about that now. So everything else is going to be very similar though. So we have our if other name is equal to player in the on trigger enter function. So we're just going to copy this whole thing here, and below our update we're going to pop it in there. And instead of our level manager, what it's going to do is we're going to call from our health manager script, and we're going to call hurt player, and we're going to pass in our damage to give value, and we're going to hit save. We'll convert this so that saves, and now we'll pop back in here. So now if we go to our enemy, we're going to put that script on him instead of the kill player script. So we'll remove this script, remove components, and we'll add hurt player on contact. Pop that in here, and we'll say we'll give 1 damage when he hits the player. So we hit play, and bam, look, our health goes down to 4, 3, 2, 1, 0. Oh no, things are going crazy. So now it has no way of knowing that the player is being destroyed. Our enemy's health is set to 0, and there's nothing telling it to stop being 0. So in our level manager, we have to adapt that now. So we'll go into our level manager here once it loads up. So down here, this is the function that's killing the player. So when the when the health manager detects that health is less than 0, then it'll call respawn player. So we go into our level manager, and then what it does then is it plays through this thing, but then the health isn't being reset back up to 5. So the health manager keeps saying, okay, the health is 0 every frame. It goes, health is 0, quick, kill the player. And it just keeps putting the same death script over and over and over again, and that's not very helpful for anybody. So we're just going to add up here a public health manager, and much the same as room with the player and the camera here. We're going to add that in here. So health manager is equal to find objects of type health manager, and I'll do this in the start function so it does it straight away. It's helpful to use this little system, but it's only useful when there's only one instance of that object, because we will never have more than one health manager going on in the game at a time. So now basically all it'll do is it checks all this stuff, and then is there anything else we need to turn off? No, everything else is okay. So what we'll do is after it comes back alive, we'll say health manager dot full health. We'll save that, and I will pop back into the game here. So now once the player gets killed again, 4, 3, 2, 1. Oh no, he's being killed, he's coming back to life, but he's still being killed over and over again. That's not going to be very helpful for us at all. So what we can do very simply to fix that up is on our health manager, we're going to add another little variable, and we'll just make this public bool is dead. So we'll set is dead to false straight away, and then in the update section, if player health is less than 0 and also is dead is false, so not is dead, if that's the case, then what we'll do is it'll call the level manager.respawn player, and it'll say is dead is equal to true. So then what it's doing is it won't keep checking to see if the player is dead. It'll go, okay, he's already dead, so I don't need to try and call the killing the player script again. So we'll just save that, and then in our level manager, after we return him to full health, we will also go health manager dot what do we just call that? Is dead. We'll say health manager dot is dead is equal to false. So now we save that, pop back into the game here, hit that play button. Oh no, we've got errors in our health manager, line 29. So health manager 29. Oh, we didn't say and, of course. So player health is less than 0 and he is not dead. So save it, and we'll pop back into the game here, and it'll play once it's finished compiling again. Hopefully there won't be any more errors. Here we go. So now we kill him. There we go. He gets killed once and he comes back to life. So now there's different ways we could handle these spikes here. At the moment, they kill you straight away and they send you back to there, and that's fine. If you're happy with that, that's fine. But as you can see, it's not taken away from the health. So what we could do, rather than sticking with our kill player instantly script, and another very simple way to do it is if we actually zoom back in here, so we select our spike, they're prefab. So we'll remove this kill player script, remove component, and then add our heart player on contact. And instead of 1, we'll just set this to a high value. So perhaps as the game goes on, the player might be able to upgrade his maximum health level. In that case, we don't want the spikes to only take away 5 every time. So we'll set this up to a really high value, just say 50. And we'll apply those changes. So now, when we hit play, and the player goes over to the spikes, bam, he'll be dead. And it said minus 45. Actually, that's something we don't want. We don't want to say minus 45 health. That's no good. So in our health manager script, if player health is less than 0, if less than or equal to 0, we will set player health to 0. So then instead of saying minus 45, it'll always say 0 when his health is lower than that. So we'll just save and we'll go back to the game, hit that play button one more time, and we'll walk over to the left here. There we go. His health goes down to 0 and he's reset back to there. So there you go. Thanks for watching, everybody. This has been our little look at adding a relatively simple health system to the game, but it's interesting and I think it works very well. So yes, thank you for watching. I will be back soon with more tutorial goodness, and we'll fix up more things and add some more systems to the game. And in the meantime, keep watching the skies. I don't know what that means. I'll be back. Thanks for watching this episode, and if you'd like to see just how some of the concepts we've covered can be brought together into a fully fledged game, then head to portalnauts.com and check out the demo for my game that I've been working on for the last while. It uses a lot of the concepts we've covered so far in the series, as well as other things that we're going to cover in the future. So if you want to get a feel for where we're going and what kind of things you can make with these with the basics of Unity, head over there, try out the game for yourself, and let me know what you think of it, of course. And the best place to let me know is to head to Twitter @GamesPlusJames. Say hi. I'm always there, ready to say hello and do stupid things. But also, if you'd like to see some of the game being worked on and developed in real time, head to twitch.tv/GamesPlusJames, where I regularly stream development of the game, and you can get to see behind the scenes of how things all work. So head there, say hello, and I'll see you all in the near future.